This video explains how to use the Altair Embed PWM block to control the brightness of two LEDs. For the target, we'll be using the Texas Instruments F28069M Launchpad board, also known as the Piccolo. The Piccolo has two built-in LEDs. The red LED is connected to GPIO 34 and the blue LED to GPIO 39. We will control the brightness of both the red and the blue LEDs using the PWM signal. We'll approach this example using two models, a source model and a debug model. The source model is created first, followed by the debug model. The simulation is set up to simulate from 0 to 100 seconds in increments of 0.0001 seconds and to run in real time. Next, we need to identify what target is being used. Select an F28X config block from the Embed Piccolo menu and place it on the screen. Ensure the CPU is set to the target being used, in this case the F28069M, and also ensure the JTAG connection is set to TI-XDS 100 V2 USB or the JTAG you're using. All other parameters can usually be left at their default values. Under Embedded Piccolo PWM, select an ePWM block and place it on the screen. Right button to expose its parameters. Select the PWM unit to be 1. For the time-based setup, set the count mode to up-down. Set the timer period to 40. This will produce a 1 MHz PWM carrier signal, which will be fast enough to prevent any visual flickering of the LEDs. For the action qualifier, we will use ePWMA. Make sure the GPIO pin is set to GPIO 0 and set the compare A, CMPA for ePWMA to Z equals nothing, up equals 1, and down equals 0. For now, we'll use the default values for all their property settings. From the Blocks Signal Producer menu, select a slider and configure it to range between 0.01 and 0.99. We'll use the slider to produce the duty cycle command sent to the PWM block. Since the slider outputs a float data type and the PWM accepts 1.16 format, we'll need to add in a convert block from the Blocks Arithmetic menu and set the conversion to scaled integer, radix point equals 1, and word size equals 16. Now we'll connect the PWM output to the red LED. Under Embedded Piccolo GPIO, select a GPIO input block. Place it on the screen and configure it to read the PWM signal on GPIO 0. Next, select a GPIO output block and set its channel number to 34, which is the red LED, and connect it to GPIO 0. Copy the GPIO output block, set its channel to 39 for the blue LED, and also connect it to the GPIO output. Capture the Convert, PWM, and the 3 GPIO blocks into a compound block by first using the mouse to select these blocks, then right button and select Create Compound. We'll name our compound block PWM LED Control. Okay, we've got two input pins here, but we're only using one inside. So we'll disconnect the duty cycle B on the PWM and rewire A so we're obtaining only the first input. I'll rewire the output of the compound block and I will delete that second connector pin using the minus button from the toolbar and clicking on the left edge of the compound block. At this time, we'll also add an output pin. And within the compound block, I will send out the value of the converted PWM duty cycle command through that output pin. And I'll attach a plot block to that output. Before going any further, we'll save the source model as PWM control of LED.vsm. Now we'll build the .out file to be downloaded to the target. After selecting the compound block, select Tools Code Gen. Ensure the Use Selected Compound Edge Pins for Data Exchange is selected, Defaults for the other settings may be used at this time. Select the Compile button. The compile results are presented in a DOS window. Select any key to acknowledge the DOS prompt, then select Quit. Now we'll build the debug model, which will allow us to run the .out file on the target and interactively send it duty cycle commands from the host PC using a slider block. We start creating the debug model from the source model. A target interface block is obtained from the embedded Piccolo target interface menu and placed on the screen. Observe the block has the same number of output pins as the compound block used to produce it. Right button on the target interface reveals its configuration. Observe the sample rate is set to 10,000 Hz and recall that the carrier frequency for the PWM was defined as 1 MHz. Also observe the .out file generated in the previous step is being used for the download. Connect the slider block output pin to the target interface input pin and connect a plot block to its output pin. The JTAG interface has a bandwidth of approximately 1 to 200 Hz, so we will set the time step of this debug model to 0.01 seconds with an end time equal to 100 seconds and select the Run in Real Time option. You can leave in the compound block used to generate the .out file or delete it. I'm going to delete it. Then we'll save this model as PWM control of LEDs-D. Now we're ready to run our code on the target. Click Go. You'll observe the .out file being transmitted to the target. Then it will begin running. As you move the slider, you will observe both the red and blue LED dimming and brightening.